Hello and welcome back to idea.org. This is the show where I teach you idea.org. This is the equivalent to the Duke of Edinburgh badge. If you have been following along, if you have been following along, but I know I haven't done a video in a while and I just want to apologise for that. I've had a very, 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 very busy year and it's just been a mental last year for me. I hope you can understand. But anyway, we're back, and today we're going to be doing AI project cycle. AI has a great potential to transform society, and you, yes, you can create an AI project of your own. But how do you get started? Learn about the 6 stages of the AI project cycle, the 4WS problem solving canvas, and discover techniques to acquire and visualize data. Let's go ahead and start the badge. Okay, so AI project cycle. Artificial intelligence, or AI, has great potential to transform society. Suppose you wanted to create an AI project of your own. How would you get started? The AI project cycle is a framework that you can use to help with the design of your AI project and guide towards your goal. In this badge, you will learn about the 6 stages of AI project cycle, learn various ways to acquire the data needed to solve a problem, discover the 4WS and how to apply them, learn about the importance of data visualization to identify trends, relationships, and pattern present. Let's go. AI project cycle. There are many AI project cycles to be explored, but keep it simple. We are going to break it down in 6 stages. Stage 1, problem scoping. Define a goal of your project. Defining your project's goal is one of the most important stages to kickstart the AI process. If you want a good outcome, you have got to set the goal right. It's like finding the goal post and positioning yourself to kick the ball into the goal post. Stage 2 is data acquisition. Collect the data that you think you will need to train your model. A system used to imitate or replicate a specific scenario. That's what a model is. Stage 3 is data exploration. Transform the data into a form that is readable by humans. Visualize the data. Data is often visualized through graphs. Stage 4, modeling. Implement algorithms and fine-tune the models to give you the best results. Stage 5, evaluation. Evaluate the different models and choose the best one. Evaluate to assess or make a judgment about the results of an experiment. Stage 6, deployment. Deploy your solution based on the model you've selected. Drag and drop the project cycle stages into the correct order. So we know that stage 1 is problem scoping. So we'll go ahead and do problem scoping up to the top. We know that stage 2 is data acquisition. So stage 2 will be data acquisition. Stage 3 will be data exploration. Stage 4 will be modeling. Stage 5 will be evaluation. There we go. Check. So we've got that wrong. So what we've missed out? So data exploration, modeling. There we go. Modeling, and then we have evaluation and then deployment. I just got that the wrong way around. Evaluation and then deployment at the end. Yeah, there we go. Come on, deployment, move around. There we go. Have another go. Modeling, evaluation, there we go. And done. So move on to the next one. Next word. Let's dive into the stage where we'll start problem solving. Problem scoping, sorry. Problem scoping is about understanding the problem and finding out the various factors which affect it. If you have already done problem scoping with AI badge, then you will probably be familiar with the Kamichi crisis. But if you don't worry, if you haven't done it yet, you can try it next. I believe I have done this badge in the past, so if you want to go check that, you can feel free to check the channel where the playlist where I've uploaded all of the idea.org videos. But I believe it's basically like, let's say you're your AI has it has a set of instructions, right? It has a set of instructions that it has to follow. But let's say your ingredients change in one of those set of instructions. It's a problem that the AI doesn't know that the ingredients have changed, and that's what the problem scoping is about. It's about, making your AI basically intuitive. So like when an ingredient's missing, it will find something else to then replace that ingredient. That's what problem scoping is about. Anyway, so unusual Kisby recipes. I don't know if that's relevant with this at the moment, but we'll move on. Can watch this if you want to, although I haven't got permission to watch it. So if you do, I don't have permission to watch this on the YouTube channel. So if you want to watch it, the video is there for you to watch. Soaring Napa cabbage prices, Unit 1. So this is just a graph to show you how many cabbages prices. I honestly don't know why you would want this, but there you go. Price of types by stores. Types of stores: traditional markets, department stores, large discount chains. And then we can see how much cabbage prices increased by the stores. Would you want to buy a cabbage that is 3,175 won, or a cabbage that is 5,303 won? Won is currency, just so you know. Like most people, you would probably prefer the cheaper cabbage. In the video, because of the rising cabbage prices, people are having to find alternative ingredients to make kimchi with, or make less. Imagine if we were possible to know the price of the Napa cabbage in advance, so that you can stock up when it's cheaper and avoid having to buy it when it's most expensive. The data shows us the prices of the Napa cabbage used in making kimchi. If you look at January, the cabbage prices was 2,569 won, and in April it was 4,822 won, and subsequently it went down in June to the price of 3,175 won. And in December, it skyrocketed to 5,303 won. Press continue. The 4WS problem scoping canvas. You can use framework of the 4WS problem canvas to look into the who, what, where, and why of the problem. This helps you to understand the key elements of the problem that your project is trying to solve. You'll be able to download a template to fill in for your own projects, and after finishing this badge, but first let's work through the 4WS problem canvas together. Who? In this step we are looking at the person who is having the problem. They are also known as the stakeholders of the problem. Let's use kimchi crisis as an example. Who is having the problem there? There are the people who buy the Napa cabbage to make the kimchi, the farmers who plant the Napa cabbage for the living. Let's identify the stakeholders. Who is having the problem? People who buy the cabbage to make kimchi, farmers who plant the Napa cabbage, and people who buy Napa cabbage and farmers who plant Napa cabbage. So if we go ahead and so the people who buy it, they're all going to be, oh no, sorry, the farmers. That's what I meant to say. I meant to say the farmers, but anyway. So in this step, in this step you consider the nature of the problem. Ask yourself 3 questions. What is the problem? How do you know it's the problem? It is a problem. Is there evidence that is a problem? Information that provides something that is true. Think back to when the kimchi crisis. Now let's apply the what. Ask yourself 3 questions. The problem that the stakeholders face. The farms buying Napa cabbage to make kimchi. Is there an increase in cabbage prices and the unpredictability of the cabbage prices? You know that this is a problem because there are many new articles published about the soaring prices of Napa cabbage near kimchi making season. There is evidence for the problem. Consider the nature of the problem. What problem do stakeholders face? So, The increase of prices, obviously. That's the problem. Yeah. So where? In this step, we ask, where does the problem arise? This is where you describe context or a situation of the problem. Here, where doesn't mean the location of the problem. Instead, it's the context or the situation in which the problem is arising. This is a systems map. To learn about this more about the systems map, the problem solving with AI badge is linked at the end of this badge. A method used to understand the complex issues with multiple factors that affect each other. Let's move on to the next one. So let's identify the context or situation in which farmers and people using Napa cabbage to make kimchi experience the problem of the increase and unpredictability of the Napa cabbage prices. What is the context or the situation in which the problem is arising? During the kimchi making seasons? During the cabbage harvest seasons? Both. It's both, of course. Why? Why is the problem worth solving? This is important because it is what gives you the motivation to solve the problem. Ask yourself, what would be the most important to the stakeholders? How would solving the problem improve the situation? Let's apply why to the kimchi problem. For people who buy the Napa cabbage, buying it at a low price instead of at the highest price is most important. Solving the problem can improve their situation by allowing them to make more kimchi and save money. Now, what about the farmers? What would be a key value to them? And how would solving the problem improve their situation? If the farmers could estimate their income better, it would allow them to plan ahead. That would be my option. If the farmers have access to social media, then they can communicate. Oops, Daisy. I did not mean to do that. Farmers could communicate with other farmers to plan their harvest. The farmers need Wikipedia in order to learn about farming techniques. No, it will be this one because they need to be able to see data ahead of them to be able to act upon that data. Now find the 4WS. Can you find the 4WS from the 4WS problem scoping canvas? Workshops below. So we've got to find 4WS. So problem scoping canvas. Let's have a look at that. Let's have a look. What we've got here now. Let's have a look around here. So what is it we're looking for? What is it we are actually working? Can you find the 4WS from the 4WS propane cameras? From the 4WS. So would it be like the word farmer or something? Or would it be Napa? That's a good question. I don't know. This doesn't really help. This is a bad question. Find the 4WS. Can you find the 4Ws from the 4Ws problem scoping canvas in the word search below? It doesn't really make any sense. It doesn't really make any sense at all. We're looking for the word problem. Let's have a look for that. P. No. I don't get what we're supposed to be looking for. I mean, higher. That could be one, couldn't it? No. Let's just try and... No, I can't do anything. This is a really, really annoying one. Why is it so, vague? Doesn't make sense. Can you find the 4WS from the problem solving canvas word search below? Doesn't make sense. What? Oh, that's one. Okay, what's one? Okay, what? Oh, what? Where? We need to look for the word where. So let's look for the word where. Where? There we go. No, we need a H. Where? We also need the word when. Let's have a look. Where are we looking? So what? When? We'll look for it. Who? So what? Who? Who? What? Where? 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 Want? So look for the things that we've just been doing. Who? What? Where? So we need to look for the word where. You've probably already found it by now. It's got to be somewhere around here. Where her? Where her? Can't see the word where her. Where's where? Where? We need where? Oh, there we go. Where? It's backwards. Where? And then we have Y. So we need to work for WHY. WHY. So WHY. WH there we go. Next. Okay. Data acquisitions. Now that you have finished problem scoping, you have reached the stage of data acquisition. Data acquisition is the process of gathering data you can get data from. Surveys. A survey is a research method that uses a list of questions to collect specific information from a designated group of people. An API, an application programming interface. A API is a set of procedures that enable you to access data that you require on the web. Sensors. A sensor is a device that detects and measures something that converts the measurements into electronic signals. Observations. The action of monitoring something carefully in order to get some information, e.g. behavior, observation study. Government open source data. Government open source data is data that is published by the central government, local authorities, and public bodies. For example, data.gov.uk. Web scraping or scrapping. Web scrapping is the technique used to extract large amounts of information from websites and storing it in your computer. What is data acquisition? It is the process of gathering data. Continue. Data exploration. Once you've collected the data you need, you will need to explore and visualize it before you can make an AI model. When you pick up a book, you probably tend to look at the book cover, read the back of the cover, and skim through the content of the book before choosing it. This helps you to understand if the book is appropriate for your needs and interests. Similarly, when you get a set of data, you need to spend time exploring it to help you get the sense of the trends, relationships, and patterns present in the data. Exploring the data is in this way will help you decide on which AI model or AI models to use in the next stage of the project cycle. That's modeling. We use data visualization as a method because it's much easier to understand information quickly and communicate the story to others. You can learn more about the concepts of data visualization on the IDEA Bronze Level Data Visualization badge. You'll find the link at the end. Which would be more useful for quickly exploring data? This would be this. It would be the table here. Nope, it wasn't. The graph. The graph. That's what I meant to say. The graph. Okay, next. Modeling. In general, there are two approaches taken when researchers, when they build AI models. They either take the rule-based approach, when humans give the computer a set of guidelines to follow the processing data, or learning approach, when data is given to a computer and the computer looks for patterns in the data. One rule-based approach is a decision tree, a type of flowchart that shows a clear pathway to a decision. So let's say if I was going into a shop, for example, and let's say I had a till or something, right? And it's saying, like, basically, a decision tree is basically like, if I say to Siri or something, so as I said, if I'm in a shop, right, and I go to the till, and let's say that this is an automatic till for the purpose of this video, and I ask the till, I would like to make a purchase. It would then tell its system that basically it would say, yes, you can either make a purchase for the price or you can cancel out. It's basically a set of instructions that the program or the instance should follow. And that's what a decision tree is. So a learning approach requires machine learning. Machine learning, or ML for short, enables machines to improve their tasks with experience. So machine learning, for an example, well, that basically just means that let's say one customer likes to buy a carrot and one customer likes to buy a bottle of milk, for example. Over time, it would recognize that this customer wants a carrot and this customer wants milk, and that's what machine learning is. So moving on. In machine learning, you will provide training data and the machine will undergo a training process and produce the model for you. Through training your model, you will incrementally improve your model's ability to provide you with an accurate solution. Unscramble the letters. In blank, 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 blank. You provide the training data and machine learning will undergo process and produce the model for you. So machine learning is what we need to put in there. So M. Oh, this is weird. What's going on here? Oh, just to spell it. So what's the word? Rule-based approach, maybe? I'm not sure. Unscramble the letters. In what is it? What is it? What are we trying to spell here? What we're going to do is we're actually going to just go ahead and look up word unscrambler, and then we can go ahead and we can just type our letters in here. So MRGE, 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 IANN, IANN, IEN, IEN, ACHL, ACHL. Unscramble. Okay, we've got a lot of letters there. So chair manning, rescaling. Let's have a look at what makes sense. There's a lot of options actually, but it's going to be one of these. So let's have a look at these. Chair manning. Let's try chair manning. So C H A I chair M A N N I N Manning managing. I'm not sure, to be honest with you. Rechanneling, that might work. Channel channeling. So we got CH in the correct place. So let's try and rearrange these. So we got A in the right place. N is in the right place. So bring the N across here. The H in the right place. Okay. Let's get the first letter, I think. It's probably the best to start with. So C, R, E, H, G, I, M. So M's the first letter. So let's try M, A, M, A, G, M, A, N, M, A, L. Feel a bit of trial and error. M, A, I, M, A, E, M, A, C, M, A, C. So it is machine learning. Yes, I thought it was right. M, A, C, H, then it should be a H. Yes, machine. And should trust your instinct more. Machine learning. So LEARNING. Learning. So they're opposite around. There we go. I was right. Let's move on. Evaluation. In the evaluation stage, you want to test the performance of your selected model. It is able to provide you with accurate solution. Testing the performance of a model is very similar to performing the scientific test or an experiment. To carry out a good experiment, it is important to first identify which variables you are testing for and what the control variables are, the variables that remain consistent between tests. Next, you will need to give your data some structure. You can do this by identifying patterns in your data. 3 methods to do this are classification, placing data into different categories using labels. Example, your email uses a classification algorithm to label whether it's an email as spam or safe. Regression is finding a probabilistic relationship between variables to make a prediction. A connection to 2 variables are likely to have. An example would be using regression algorithm to predict the piece of kimchi given variables like rainfall, temperature, and cabbage prices. Clustering, grouping data into different clusters that share similar characteristics. Example, Netflix uses clustering algorithms to group together people who like similar types of movies. Once your data is structured, you are ready to use a performance measure. Take a look at examples in the table below. Data structure, performance measure, example, classification accuracy, the rate of accurate predictions made, regression, mean absolute error, the measure of a difference between actual values and the predicted values. Clustering, internal evaluation, uses the internal information of the clustering process to evaluate the goodness of the clustering structure without using any external information. When you're testing, you want to carefully check your model's ability to provide you with an accurate solution. AI projects revolve around data, and data is one of the things that testing that is guaranteed to consistently grow and change. Because of this, you will find that your AI projects are continuously growing and changing. The more data you work with, the more meaningful the test result will be. You should meet a level of accuracy that you or your team dream acceptable before moving on to the deployment stage. Why do you want to test your model? To see how hard it is to break your model? To see if your model is better than your friend's model? To check the model's ability to provide you with an accurate solution? That's what you want to do. Yes. Let's keep going. Mean absolute error is the performance measure of which type of algorithm? That is mean absolute. That's regression. Yes, let's going. What is the one thing in testing that is guaranteed to consistently grow and change? That's data. Yes, let's go get going. Deployment. You have reached the final stage of AI project cycle. All the work you were doing earlier has led you to this final step of deploying your model to production. Now you will actually be using your model to predict outcomes in the real world. By this point, your model should meet the threshold of accuracy that your team have deemed acceptable based on the testing that you have done in the evaluation stage. In this case of the kimchi crisis, a 16-year-old Kim Han-seo from Busan Computer High School deployed his linear regression model using Python and trained it to predict the price of cabbage based on the temperature and rainfall data. A programming language is what Python is. I have done a Python video in the past. If you wanted to see that, make sure to check out my playlist where I've done a badge on that. So we'll move on. What are some important things to consider during the deployment stage? Consider the ROI of deployment, root of interest in that, the return of investment, and the measure of cost of investment relative to the gain. Sometimes the cost of deploying a model into production is higher than the value it would bring, and knowing this will help you and your stakeholders decide if the deployment is worth it. What are the risks of deployment? Is it important to analyze the model performance with your team and your stakeholders to determine what the risks of deployment are and agree on a level of risk that is acceptable to inaccuracy? Is your model easy to replicate? Think about how this model can be reused in other contexts or departments or regions to help solve problems of the world. Here's an example of that. For example, basically, a kiosk in a shop. That's an example of this. It's a model of a system that's deployed in multiple places. So you've got, for example, you've got McDonald's, you've got KFC. They all use probably the same model, but it'll be a different model, basically, what I'm saying. Like, they'll use the same structure. You know, you'll have the same kind of interface for the user, but it may be a different model that's used to deploy that. And that is an example that I was showing you here. So do you have a feedback loop in place? Mechanisms that are used to validate and get feedback on how the system is performing. Before your model is deployed, it is a good idea to design a feedback loop so you can collect more better quality data and correct any mistakes your system may be making. Let's put this as an example as well. So let's say, for example, your local council wanted to make some changes to a pavement, right? You may, first of all, you know, on paper it might look good. You might, this change is going to be better for our residents that live there. But when you go and get a survey done for the residents, that it comes back and it's like the residents do not want this change, as an example. And that's what a feedback loop is. It's putting things in place before you've deployed it to know if that is going to be what people want. It's what people want to look at. It's how the system wants to perform. And that's what the feedback loop is. Ethics. The ability to create powerful AI modules has the potential to improve many aspects of our lives, but it could also create problems such as perpetuating historical biases and stereotypes. Carefully consider all potential short-term and long-term consequences of deploying a model. Even well-intentioned systems can have unintentional harmful effects. So there's a big dilemma in the world at the moment. So the dilemma is that if you have AI in the world, like if you have artificial intelligence, you know, the internet is full of racial abuse. It's full of it. Now, it uses the internet to, as a model, it uses the internet to get information from. So there's a big dilemma that AI, if we create a super powerful AI, so to speak, it will become racist because it doesn't understand racism as to the extent that a human body does understand it. And that's what it means by ethics. Is it right? Is it the right action it should be choosing? Or is there another way around that it can use, basically? So let's continue. Let's recap. Can you remember the order of the AI project cycles? Drag and drop them. Okay, so wasn't it like... Oh, what was it now? It was... I know deployment was at the end. Deployment, and then it was evaluation, and then it was modeling. I think that's it, actually. Okay, no, we just need to change that around. There we go. There we go. Good. Let's continue. Congratulations, you have successfully completed the AI Project Cycle Badge, and you've been awarded 10 bronze points. In this badge, we have already gone over this, so we don't need to read it again. But we can download the Canvas worksheet so you can keep it and fill in your own projects. Why not? Let's have a look what this is. Oh, cool. So this is actually really cool. I will leave a link to this in the description if you do want to go ahead and grab this sheet for yourself. It's actually a very, very, very interesting sheet. Very good way to visualize what your model will look like in the end. So let's go ahead and press return to IDEA. There we go. So thank you for watching. If you didn't want to see more of the IDEA in the future, make sure to drop a subscribe button down below and comment below what badges should do next. Thank you for watching. My name's Ryan. I'll see you guys in the next video. Peace.